everyone. Today our group will be give a presentation about disposable waste for water. Our group consists of Kamila Maharani, Patricia Gabriel Emily, Muhammad Safwan, Jessica Felicia, Habiba Ardelia, and Cika Ramadan Zuhri. Introduction. The disposable plastic bottle usage for drinking water, making the number of plastic bottle trash keeps increasing every day. While a lot of student and daily worker needs everyday supplies for drinking water, our idea is to provide a self-service public automatic water dispenser that will provide drinking water to refill the tumbler, and with the cooperation of trusted local drinking water companies, the vending machine will sell water in volume-based refill. The main objective is to reduce plastic bottle usage. And the second one, according to the Solar Impulse 2022, plastic pollution is caused by the accumulation of plastic waste in the environment, and it can be categorized in primarily plastic such as cigarettes and bottle caps or secondary plastic, resulting from the discretion of the primary one. It can also be defined by its size from microplastic into smaller particles. The factors that contribute to plastic waste according to Solar Impulse, its global production that growing exponentially. Its success comes from its remarkable qualities, ease of shaping, low cost, mechanical resistance, and etc. Being the ideal materials for packaging, plastic is basically everywhere. Example of our 19% of marine litter is came from plastic. So, according to the Water Orangi, Indonesian lacks safe water and 2 million lacks access to improved sanitation facilities. We made drinking fountains because they are perfect for any environment and parks. These machines are ideal, compact, and suitable for a space-conscious environment. And easy to use, you can simply place your water bottle in the designed space on the fountain, and it gives you full access to the purified water that has beneficial to your health. Simply placing your water bottle in designated space on the fountain gives you full access to the good water.
So for problem formulation, human beings have certain basic needs. We must have food, water, air, and shelter to survive. In other words, we need to agree that the water resources have become the most prominent aspect of human beings to live. But what if some areas experience water scarcity, and how would they live? So there are three main points that I want to explain. The first is lack of water resources has happened in Indonesia, such as Java, Bali, and Nusa Tenggara. These areas have difficulties to suffice their water needs, approximately around 1,500 and until 2,000 liters per day per capita. The second is, on the other hand, disposable plastic bottle usage for drinking water make the number of plastic bottle trashes keep increasing every day. And the last, while a lot of students and daily workers need everyday supplies of drinking water, they are forced to buy bottled water because in Indonesia, tap water cannot be used for drinking water. There are still a large number of people willing to bring their own tumbler or reusable bottle, but they were not facilitated well to fill their bottle when it is running out of drinking water to drink in public places. Next, solution concept formulation. According to the previous made free public water fountain in Indonesia, we acknowledge several evaluations to consider. The first is this machine might not be made for every group of people. People often misuse the water provided. Users are not quite aware of plastic reusable campaigns. Developers lack of interest in maintenance. A massive amount of grant is needed. And solution sketch. In order to prevent the misuse of the water, it will not be free. We propose that the market should be able to treat it more appropriately and not arbitrarily, despite the fact that it will be a public facility. People should require plastic bottle payment for some reasons. The first, recalling the fill of water, ensuring people's trust in the water quality provided, and plastic payment is an absolute win-win solution. Finally, as there will be a massive branch, we will need several vendors to be trusted in this project with cooperation with several companies for minor water, filtration, maintenance, plastic recycle, antibacterial copper plate, and project funding. Next is design of disposable waste for water. The figure 1 is logo for disposable waste for water, and the figure 2 is composition of logo. Next is the brainstorming of the machine design. For the methodology, you can see in the picture. And next is working mechanism of disposable waste for water. So for the flow chart, start, input plastic bottle, must input the valid plastic bottle. If it's false, it's not gonna processing, but it's true. Calculating plastic weight, please input the plastic bottle with more weight. If the weight is more than 50 gram, then is continue to is the weight more than 1,000 gram. If it's true, display tumbler choice, input choice, give out the tumbler through a vending system and open the tap water. But if it false, directly open the tap water end.
So this is the 3D animation for the machine of disposable waste for water. So the first thing we have to do is to put plastic bottle in the cabinet. And then after we put the plastic bottle, the machine will read the weight of the plastic bottle that we just put in. After that, we can operate the water dispenser in one click with the amount of water that we need. And if we put a heavier plastic bottle, in this case is 1,000 gram, the machine will offer us to choose a tumbler from the cabinet below. For example, if we choose number 4, the tumbler will be dropped by the machine and we can take the tumbler from the box below. And we can also operate the water dispenser in one click with the amount of water that we need. So that is for the 3D animation for the machine of disposable waste for water.
Okay, so I'm going to be briefly explaining our poster for the project of disposable waste for water. So the main idea of our project is that you'll be able to exchange your plastic bottles for a drink. So a few points that we'd like to point out about this project is that firstly, that there will be efficiency in reducing plastic waste. By this we mean that people will be able to collect as many plastic waste from their homes or from the environment in order to exchange for a free glass or tumbler of fresh drinking water. Next, we will have regular maintenance from several investors or partnership companies. This will ensure the quality of our drinking water as well as the longevity of each installation at your nearby location. Next, we will have innovative models because we will be integrating the process or the systems from vending machines and a drinking fountain. Next, we would like to point out that this project targets to have the most eco-friendly alternative in each of our community. We want to act as a stepping stone for companies and investors to allow their commuters and to allow the community to act and behave as eco-friendly as possible. Next, we plan to strategically place these installations in crowded locations. This to lessen the amount of plastic trash that accumulates in crowded areas. And lastly, we believe that our project is a very budget-friendly alternative to people such as students or athletes or even people that jogs often. So the commuters only required to bring plastic bottle trash from their homes, and going green can actually save money for you and your business and improve the workplace culture in the meantime. So that is the brief explanation of our project and for the poster that we will be providing to you.
And next explanation is about the material. Because the machine is built for public use, we are using austenitic stainless steel for the materials, where the physical characteristics of the austenitic steel are as follows. It has a gray color, although some have a white color, and the austenitic stainless steel has a density of 8,000 kilograms per cubic meters. And for the chemical properties, austenitic stainless steel is made out of several elements, such as chromium, nickel, sulfur, and silicon. And austenitic stainless steel also have a great electrical and thermal properties for this machine. Moreover, recalling how the major frame of the machine will be used to store plastic waste, for the bacterial features must be considered to avoid microbiological activities. That's why we are using antimicrobial copper for the framework and the cabinets. There are several reasons why we are using antimicrobial copper for the framework and cabinets. The first one is antimicrobial copper can kill more than 99.9% of bacteria that cause infections within 2 hours of surface contact. Antimicrobial copper can continuously kill bacteria for 24 hours a day, even after repeated contamination. And for the durability, copper is among the most durable metals on the market, with little deterioration or corrosion over time. And the cost of antimicrobial copper provides an opportunity for strong positive returns on your investment. Antimicrobial copper is also made from up to 100% recycled copper and is 100% recyclable, making it an environmentally friendly solution for the materials of the machine.
Next is our cost estimation. First, there's stainless steel. It's like the main material used to make the outer composition. And like the outer aerator kit is to filter the debris. And ventilation kit and fan is to fountain pump and control generate heat and will require that the room to be ventilated. Drinking fountain head and basin, it has to made of non-corrosive material. Drain kit is for the residual liquid or water that splashes from the basin will continue to the drain system below the drinking fountain system. And the shroud, because these drinking fountain with shrouds are ideal for areas where pipework and traps need to be concealed. Polytubing is like polythene tubing. It's flexible, lightweight, and durable corrosion-resistant plastic that can be used for a wide range of liquid, gas, and fluid transfer applications. Coordinate valve is for the valve, and gasket is a foam that has a flat bottom to seal the drain assembly. Cartridge regulator is a cartridge connected to a handle and reset within a valve. Filtration system is, well, a filtration. Plastic fitting is like a plastic that will be used to fasten the wiring and protect the electrical system. Capacitive sensor is a sensor used to detect the plastic received by the drinking fountain. Water cooler system is because the central chilled water assembly is needed to cool, so we need a system for that. And for the hardware and fitting is included cartridge holder, lock nuts, and other regulators. Temperature system is like thermostats, regulators, and other electrical components. And maintenance kit is like a repair kit that will be provided after installation. And from our table here, it is estimated that the machine will cost 500,000 million, though it could be higher since we only listed the primary requirement. And all the prices listed here is reference from USD.
So as engineers, our groups are quite challenged to formulate two major environmental problems encountered in Indonesia: water scarcity and plastic waste. While water sources are still distant for many households, some of them are contaminated. Thus, household sanitation still remains unavoidable. On the other hand, as plastic solutions can't be recycled, the process of collecting and processing materials would benefit the environment. Other than being thrown away as trash, recycling can benefit the environment. Moreover, plastic recycling is the method of gathering waste of plastic and converting them to new and useful plastic products. Therefore, our group created the innovation of a drinking fountain where you can exchange plastic waste for clean water, which aims to maintain the sustainability of the environment, named Disposable Waste for Plastic. And as we realize that our innovations, our designs are still far from perfect, we notice several limitations in making this tool. One of them is the cost of making the machine. Therefore, our proposals and presentations here, we aim to be able to explain and give confidence to several investors to provide financial assistance for the sustainability of this tool that will eventually help the environment.
The next point to be considered is the maintenance systems. In fact, to thoroughly clean the pump, the fountain needs to be taken apart and removed. It is actually a good idea to have a good relationship with a company that can consistently service our dispenser and ensures that our money is worth in a long term. At the end of the day, it is still far more cost efficient and environmental friendly than buying bottles of water. So overall, the disposable waste for water program is a worthy asset to prosper the society, resolving water scarcity and plastic waste issues. In fact, this will be a win-win solution towards the occurring matter that humanity encounters, especially in Indonesia. However, recalling that its main purpose is to serve the community, the profit taken from the system will not be much. In fact, the operating system of advanced technology will not cost less. Sponsorship from big companies, as mentioned before, shall be needed to fulfill the service mechanism and material supply. It might be a lot of work to strive for. However, it shall be an equal in paybacks. The next thing that we as developers realize is that this machine might not be meant for all groups of people. The implementation of the highly complex technology might not be suitable for people who are technologically illiterate. The complexity of the system makes it more suitable to be placed in busy and metropolitan spots such as school boards, parks, train stations, gym, and beach, as we elaborated before. I think that's all from our presentation. Thank you for listening.